Hi, this is Bryan.D, and I'm back with my solo project. So what I did for my personal project was a navigation map, and so let's just dive right into it, shall we? So looking at the data H, I made a struct called navPoint, and this is basically what I use for my navigation points. So it stores its grid X and its grid Y in the navigation map, um, as well as the total distance traveled, which is used for the navigation algorithm. Its world position, the previous nav point, also used for the navigation algorithm that we'll look. All the connections, once again, navigation algorithm. Uh, Whether or not it needs to be deleted. So that's if it's within a static, or if it's at a static and it's not above where and it doesn't meet certain qualifications that we'll look at in a couple seconds. Um, and then uh, so it's got its default constructor, destructor, and disconnect methods for disconnecting from all of it. Uh, Obviously, accessor for just getting the point. And then destroy. This is a recursive function called when destroying the navigation map that is called at the one of the corners. Right, it's at 0, 0. And then it basically, instead of me having to iterate through the entire map, I can just call this, and it uh, calls destroy on all of its connections, and then deletes itself. So it's basically its own deconstructor or destructor. Um, so now, let's go into navigation map. It is a child of class drawable, so that we can draw the navigation map. And it has one method, navigate to point, or I should say one public method, navigate to point, because no user should actually be creating a navigation map themselves. The navigation map manager will create it for them. Um, and yeah, so I store the map as a double-layered vector of nav points because I need to be able to access certain spots in the map easily. And I originally was using lists, but lists don't allow or aren't as good at. They're great for stacking and unstacking and creating like lines and stuff, but they're not great for actually needing to navigate through um, and getting different points. Um, so yeah, let's go ahead and look at the actual creation of it. So here's the creation of it. So what I do is I uh, take in the location. So this is the middle of the navigation map. The width that they want, the height that they want. So this is the X, this is the Z. So the max step up is how high uh, a point can be above the ground. No, not above the ground, but above its last point to actually be on the navigation map. So if it's too high from one to the other, then it won't connect them. And then distance between is how common they are. So we'll look at the actual navigation map manager in a second. But basically, so it's a double for loop that runs through and basically creates a giant square with or rectangle with equal spacing. Um, and then the interesting thing though is it goes into the it gets the ground position for it, and then at the beginning of the scene when statics are put in, um, and we'll take a look at the statics in a second. It's a helper class that I created for this. It's like it's a game object class, so it's just like drawable or collidable or anything like that. It's just inherited when they create it, and I'll show you an example. Um, and what it gets is it gets the AABB for the actual for the static, and then it uses that to calculate whether or not it can go up on top of it. And if it can, then great. If it can't, it pushes it back onto a list for deletion and puts deleted in there. Now the reason I don't immediately delete it is because I need everything to be in common grid position. Um, so, and for that to work, at least during the generation, I need it to be in common grid position. And for that to work, I need all the spaces to be filled in the vectors, and we'll see why in right now, actually. So the reason why I need all the spaces to be filled is because the way that I connect them is I basically do the math of, hey, can I go back one row, up one row, and connect those? And if I can, then I connect them. If I can't, then they won't be connected. And then I loop through back again and do it all again. So now I take out the bad points and I grab them and then erase the list. Yeah. Sorry, I was getting confused by that. I erase it from the vector, and then I actually delete it. And when I delete it, it disconnects it from its constituents because of the destructor called disconnect. So draw a nav map. Obviously, draws a nav map. It just calls visualizer and show an AABB with -1 and +1 for a marker on it, and we'll see that in a second when I start up the demo scene that I slightly changed just to show this better. Navigate to point. This is my navigation algorithm. So this is pretty much the bread and butter and why you want this. So it uses an A-star algorithm based on Manhattan distance to navigate. And it's great for the user because it just means they don't have to create some algorithm for path finding, and they can just use this and very easily get a functioning AI. And I will show you what that looks like right here. So basically, all they have to do is so this is my enemy, right? And all they have to do for navigating to a certain point is one line. They get a list of points that they need to travel to. And they just call this one line, give it the position, and then the reason this line's so long is because it calculates a random position, but they give it a in position, and that's all they do to get it. Nav map is in the game object. There is, or actually, no, nav map is in, I think this object just has a nav map reference. I'm trying to think of where I put that, but I am not positive. Anyway, sorry. But yeah, so that's all they have to do, and it's super simple for them to get. Now, the nav map first searches the actual nav map, and the reason it actually has to iterate through all of them is because it's not a square, so I can't use the same method that I did on the terrain point of just calculating, the total distance of the whole line divided by their actual x and z. I have to actually go through because there are things in the middle that are taken out, so cells can be missing, and if I didn't go through it this way, then it wouldn't actually be able to find the right point. Now, I used lists of nav points because they can be easily used as stacks. I don't need to actually get into the middle of them. And this is right here is the A-star algorithm. Yeah, if it's outside, it will just get the nearest position to it. If it's inside, It'll obviously get the nearest position to it, but if it is outside, it'll just go to the edge, and then it will stop and give that back as the final position, because it's the closest position. And that's what it's testing for. It's not testing if it's actually on the position, it's testing if it's the closest. And the closest is gotten right here through this going through. And when this is going through, it's just getting the end node and the start node. And then we just head on through. I have had experience with search algorithms in the past, thanks to the Foundations of AI class and the Game AI class, where we learned how to use these methods to find stuff in search areas, and it was I like those classes. Yeah, and then what it does is it goes back through and gets the current and basically pushes it onto the path. So it basically goes backwards, so that the front of the path is the last. And so yeah, and then it goes through all the used nodes and sets the total distance to 0 and the previous to 0, and then returns a pointer to the list path. That way the actual object owns path, so they can delete it, as we see right here. So the actual user will own that path. So now let's go into the actual manager. The manager, originally what I was going to do is I was going to have it use like the same kind of thing that Unity does, where it goes through and goes into and creates a whole file with vertices and information on each cell, and then would just load in the file at the beginning. The reason I did not go that way is because I realized that loading in all that information would take just as long, if not longer, than the actual just generation of it. So I decided just to go ahead and generate it when they call the bake nav method, which is called in the scene right here, for instance. And they get a bunch of variables they can put in. This is in the scene, and then the scene calls the nav map manager to bake it. So now the nav map manager right here has a few different methods for you can show the nav map through it, register the statics. It is a singleton, and it just has a vector of the statics, which for statics, I don't actually include the actual game objects model for space. I just include vectors, so I can generate AABVs. Now, to make sure that there's not another nav map with the same name, I do a check really quick to make sure that it's not in there. And what I use is I also use an unordered map, because I don't have to iterate through them. I only have to access them. Now, and I have a few methods for deleting them, clearing them, getting them, showing them, hiding them. The reason I don't have a check on deleting is because if it's not in there, it will. It's not like it's going to throw an error or anything. You know, if they want to call that and waste some time, I'm personally not going to stop them, because it's not going to affect the actual game. So clear all nav maps. That's called at the end of each scene. Let's look at the static class really quick, and then I'll do a little reflecting on the project. Helper tools right here. So static object. So as we can see right here, it's super simple. All it does is when you give model to navmap manager, which is called by building right here. So you give model to navmap manager right there, and all you do is you give it your world, and you give it the model, and it constructs the AABB off of that, right here. So instead of having to go through an entire huge method call for them, it's super simple. And since they inherit static, then this is already in their class. Yeah. So, a little bit of reflection time. What did I learn going solo on this? Well, I learned some research techniques, honestly. Finding out, because Unity and in Unreal both have navigation maps, but they don't. They're not going to tell you what's going on in them, obviously, because that's proprietary information. But basically, I had to determine what about was going on and how I could get the same kind of behavior with my much more limited skill set than theirs, probably. Very likely. And I think I did a decent job of that. The only thing that I would change if I could is I would go off the actual models of the model. So like, go through the vertices and figure out which are on top, and then figure out if I can put, nav points on there, which would obviously take a lot more performance, and at that point I might want to consider actually doing the baking of the nav map. That being said, since I only use AABBs, I think the baking of the nav map was a bit much, and that's why that did not make that did not come into the final, because it would have been overkill, honestly. Yeah. Let me show this really quick. So I edited the demo scene very quickly to be a better representation of the final project. So all I did was I took out the tanks, and I made the navigation map smaller and put the step up to 300 and the in-between to 30. So what that's going to do is now, if I can hopefully, so we see the navigation map now. We can obviously see it on the ground. But what we also see is up here is we see the navigation map points on the actual object. So that means if an enemy tank was coming through here, they would go do right up there. But they actually wouldn't be able to come back down onto here, because with a step up of 300, it would definitely go up there. However, with a lower step up of, say, 50, for instance, it would go up there and then wouldn't be able to come back down here. So if it got something like right in there, it would probably go there. So as we can see, it sticks to the ground. An unintentional side effect was on the tanks, the enemy tanks, since I made them actually face towards the objects, they actually ended up going with the curvature of the terrain. Also, in my game, I forgot to showcase this. The camera doesn't go through the terrain. It comes up and goes right on top of it. That way, a little bit more professional. No clipping. I think that it actually worked out very well, and does exactly what I like it to do. The enemies were very easy to set up because of it, because you don't have to create a whole algorithm to do it yourselves. And I know that when before I had taken those classes and I knew how to do those, it was a big pain setting up things to go towards things in games. I'd pretty much have them go like straight line. Uh, and so that being a tool just in the engine for the user to just have at their disposal is, in my opinion, huge. And helps out their game production time and effort a lot. Um, yeah, thank you. So that's my system.